Hello, welcome to my channel. My name is Solo Anch, and in this video we're going to find the area of this blue region. Alright, so you notice that this is a quarter circle with radius 4. Good. So how do we get started with this? Well, I guess you've tried this already, or maybe if you haven't, just pause the video and try this first. Okay, so let's see how we're going to start. Well, I'm going to start off by partitioning this. As you can see, it doesn't really look nice enough. So I'm going to partition this right here. Let me use red for that. So let's cut this out from here so that we cut this quarter circle into 2 equal parts. In other words, giving us 1/8 of the original circle. All right, good. So it is into 2 equal parts so that the region here, this part of the blue region, maybe if we call it X, it's going to be the same thing as this other part. So let's just also call this X. Maybe let's call this Y. All right, and then this part will also be Y. Good. Maybe let's give this empty side the names Z, so that they are equal like that. So I'm using this to just make sure I don't write on the light, and the light I'm using anyway, so that the area of the blue region which we're looking for, maybe let me use AB to denote that. Area of the blue region will be, well, let's see, the area of the blue region will be given by the X plus Y plus Y. Right, that will be 2X plus 2Y. So our interest is in determining the values of X and Y, so that when we put it in here, or we put them in here, we're going to get the area of the blue region. So let's see how we can get started. Well, first of all, I'm going to notice that this right here is a semicircle. So you look at this right here, it's a semicircle. By the way, if you enjoyed this video, please do want to subscribe to my channel and please share this video with your friends. All right, okay, let's continue. So notice that this right here is a semicircle with radius as 2. So see, from here to here is the radius 4. The semicircle will have its own radius as 2. Good. So what we have to do is to find the area of that semicircle. But this semicircle consists of, so I'm not really going to specify the thing, but you just notice that the semicircle consists of X plus Z. That is, it consists of 2X, all right, plus Z. And since 2X plus Z is the area of each of these segments of the semicircle, okay, adding them together will give us the area of the semicircle, which is half of the area of the original circle. But in this case, the radius is 2, so that will be half pi r squared. But the radius in this case is 2, so that will be 2 squared. All right. So notice that this right here, which is 2x plus z rather, will give us, well, 2 squared is 4 divided by 2, that's 2, so we have 2 pi. That's very nice, isn't it? So maybe let's call this equation 1. It is very important to take note of that. Good. Okay, great. So let's think about something as well. There are very many things you can determine. All right. So notice that since I've partitioned this quarter circle into 2, each of them will be 1/8 of the original circle. So you want to find the area of this quarter circle, given that this quarter circle consists, sorry, not the quarter circle, the 1/8 of the original circle consists of X plus Y plus Z. So I'm just going to put down that X, okay, plus Y plus Z, which are the area of the 3 segments in the 1/8 of the original circle, will give us the area of this, which will just be 1/8 of pi r squared, right? But in this case, the radius is the original radius given, which is going to be 4 units. So that will be 1/8 pi, then 4 squared. Let me see that showing, okay? 1/8 pi, then 4 squared. Good. But notice here that 4 squared is 16. 16 divided by 2, that's 2 pi. So this right here is going to be 2 pi, and we call that X plus Y plus Z. Maybe let's call this equation 2. Okay, so this is equation 1, this is equation 2. Well, notice that the right-hand side of both equations are equal. That's very nice, isn't it? Oh, see, observe something. This is Z. This right here is Z. And X plus Y equals to 2X. That means Y must be X. In fact, so we can notice from something very interesting here that from equation 1 and 2, okay, what we see is that X and Y are the same. Maybe let's call this equation 3. What that tells us is that the area of this part will be the same thing as the area of this part. Well, the diagram may deceive us, maybe because I'm drawing by hand, but that is what this ensures that we'll get. That X and Y will be the same. In other words, the area of this part will be the same thing as the area of that. So once we know X, we know what Y will be, isn't it? Okay, that's very nice anyway. Okay, let's see what else we can consider, because we need to know what the value of X is in order to determine what the value of Y is, or maybe vice versa. So let's see. Well, let's notice something here. If I split this right here into, maybe I called this semicircle, right? The semicircle we used to get this into two equal parts. Notice what we have for this half of the semicircle. This half, we're going to have this diagram. So let me just try to draw something out. So this is it. That represents the x outside, which is more like a conic cap, right? And then this right here is the triangle, and then this one is the inside x region. Good. Such that now, since this is a semicircle, this semicircle, the radius is just 2. So this right here will be 2, this right here will be 2. But we can partition, or we can split that into 2. We're going to peel off this part that will be to peel off that region of x, all right, out like that. And then we add it with the remaining triangle, which contains another x inside. The remaining triangle, something like that, but this one contains another x inside, so that the base is 2 and then the height is 2. So what we'll do is to determine this x, what we'll do is to determine the area of half of the semicircle, which is a quarter of the semicircle, right? Then we also determine the area of this triangle. So what is the area of a quarter of a semicircle? Sorry, what's the area of half of a semicircle? That will be the quarter of the original circle, which the formula will be pi. The radius in this case is 2 squared, then divided by what? Not divided by 2, it's divided by 4, because this is already a semicircle, that is half of the original circle. So this one will be 1/4, that is a quarter of the original circle, all right? We equate it to x, because that is just what we have right there. Then this right here, although there is an x here, but we just want to determine the area of the triangle, which will cover everything, right? So we have the area of the triangle, which is half base times height. So half the base is 2 units, and then the height is 2 units as well. Okay, that's very nice, isn't it? So notice that 2 squared is 4. We cancel out with the 4 at the bottom. This right here will be x plus, well, that is 2. So we can get the value of x easily. This tells us that x is pi minus 2. Isn't this very nice? So we've gotten something for x. In other words, we've also gotten something for y. Not for y, like for y, all right? So that tells us that this right here, which we have, so we can say maybe therefore, that the area of the blue region is going to be what? 2x plus 2y, but x and y are the same from equation 3. That means we're going to have take the 4 times of this. That will be 4 pi minus 8. Y is it 4 times of that? X and y are the same, so that will be 2x plus 2x. Right, since x and y are the same, that will be 4x. So whatever we have as x, we just quadruple that, multiply that by 4, and that gives us 4 pi minus 8. And this result is exactly what we got when using the trick to solve this problem. And that trick, I wasn't really sure of it, but it turns out to have the exact same result. Anyway, thanks for watching. I hope this was very interesting, and please share this video with your friends. Okay, like, subscribe to my channel. It's a way to support, and we'll see you in our next video.